Hello y'all. Today we're going to figure out how to find the crucial points of 4 minus x to the second power all taken to the 2/3 power. To start out, we're going to find the derivative of that equation. The first step to do that is take that 2/3 power and multiply that by the 4 minus x to the second power, which gives you 2/3 times 4 minus x to the second power, all taken to the negative 1/3 power. After that, you can simplify the exponents and everything within the parentheses, and you get 2/3 times minus negative 2x, all taken to the negative 1/3 power. And then when you choose to simplify it, you get negative 4/3 x divided by 4 minus x to the second power, all taken to the 1/3 power. To find the y point when f equals 0 of 4 minus x squared, all taken to the 2/3 squared, you take the original equation and replace x with 0. So you get 4 minus 0, all taken to the 2/3 power, which turns into 4 taken to 2/3 power, which equals 2.52, which means the point at 0 in this graph is 0 at 2.52y. Now that we've found the derivative, let's look to see what the crucial points would be. To do that, we're going to take 4/3 times x divided by 4 minus x to the second power, all taken to the 1/3 power, and set it all to 0. When we do that, we can see, since the denominator has a x at the bottom and all of that, that there is a chance that when it equals 0, it could be a DNE. So we know at some point in the graph there is a possibility for a DNE. And since the denominator is in parentheses and there is a square there, we can take what is in that parentheses, 4 minus x to the second power, and set it to 0 and find other points. When you do that, you get negative x squared equals 4. And since there's a square there, you take a square root, and since the x is still negative, you have the chances of x equaling both positive and negative 2. When you're doing this, there is also the chance that x is equal to 0, because if there is a 0 at the top of the fraction, then it would be 0 times 4/3, and you can't really have a 0 in the numerator and it mean that it's going to be a real number. So that's why x can equal negative 2, 0, and 2 as its crucial points. Now that we have our crucial points, we now get to have the joys of plugging in different numbers to figure out what's going on between those crucial numbers. Since we have a negative 2, we need to find something that is smaller than negative 2. I chose to do negative 3. So plugging it into the f prime equation, the starting bit is 4/3 times negative 3 divided by 4 minus negative 3 squared, all taken to the 1/3 power, which, after evaluating, is 4/3 minus 3 divided by negative 5 to the 1/3 power, which, since both the numerator and the denominator would be negative, would give us a positive slope for our graph. For negative 2, when you plug it into the f prime equation, it is 4/3 multiplied by negative 2 divided by 4 minus negative 2 squared, all taken to the 1/3 power, which, after evaluating, is 4/3 times negative 2 divided by 0 in the denominator, which gives us a DNE. Now that we have found negative 2 and we know that 0 is one of our crucial points, we have to find a point in between to see where the slope is going. I chose to do -1. When it is plugged into the prime equation, we have 4/3 times -1 divided by 4 minus -1 squared, all taken to the 1/3 power, which at the end is 4/3 times -1 divided by 3 to the 1/3 power, which gives us a negative slope. When figuring out 0, we plug it in and we get 4/3 times 0 divided by 4 minus 0 squared, all taken to the 1/3 power, which gives us 4/3 times 0 divided by 4 to the 1/3 power, which is a crucial point and has leveled out. In between 0 and 2, I chose to do 1.5. When plugged into the prime equation, I get 4/3 times 1 and 1/2 divided by 4 minus 1 and 1/2 squared, all taken to the 1/3 power, which ends up as 4/3 times 1 and 1/2 divided by 1 3/4, all taken to the 1/3 power, which would be a positive slope. When you plug in 2 to the prime equation, you get 4/3 times 2 divided by 4 minus 2 squared, all taken to the 1/3 power, which gives you 4/3 times 2 divided by 0 to the 1/3, which is our second D&E. Now that we have our 2 and we know that is our other last crucial point, we need to figure out what is larger than 2 and its point on the graph. So I chose to do 3, which is f prime of 3 equals -4/3 times 3 divided by 4 minus 3 squared, all taken to the 1/3 power, which at the end is -4/3 times 3 divided by -5 to the 1/3, which would end up being a positive slope. As you can see on the graph here, I have all the points put up top that were not crucial points, and whether or not they were positive or negative, and at the bottom, which way the direction would be for the graph. For -2 and +2, I put that they were crucial points because of the D&E. We can't necessarily find the exact point for it. And given that f prime of -1 and f of 1.5 both go up and down with 0 in the middle, I called that the relative max out of base assumption. And as we can see from the graph from Desmos, the point of 0 is a crest, and the +2 and -2 are sharp changing points, which explains the D&E, and further explains that the problem and the work that I have done and explained is correct.